ইনভার্ট লেভেল একটা ধর থিসি লাগা আছে সব বসা বসা সব রেডি করে স্যার ক্লাস আছে না ক্লাস আমি ফটো করব হ্যালো আছে আমি এদিকে আছে আমার রুম আর এখন
Hello, good morning to all of you. Can you hear me?
Good morning, sir. We can hear you.
Okay, great. So how are you? All of you? Having break of a week? Are you okay now? Are you all right?
Yes, sir.
All the classes and loads and whatever we have. Are you okay with the comfortable zone?
Yes, sir.
Okay, so how about you are thinking of your exam? So I will advise all of you to please discuss with your fellow friends from other department also, because we have 2 exam left from your 3-2, and then we are almost about to finish the 4-1. Okay, so if this situation continues, then we might have to go for 4-2 also. But meanwhile, you have to please discuss with your fellow friends wherever other department also, just to make sure like you are discussing, you are well prepared for your exam, how you basically thinking of giving the exam. So that is also important to get your feedback on time. Okay, so it could be good if you can start discussion with other department also and make a kind of a proposal like what you are thinking, what should be the best possible way for all of you to manage the exam leftover in case the situation really goes like this. I mean the online system. So you better start from I mean time on hand rather than like 15 batch. So we are really struggling. I mean it's almost a year now. Okay, so that is something else apart from the class. So today basically let's start our discussion where we left. I think we discussed about if I'm not wrong, we start discussion about waste stabilization pond, which is biological treatment, and primary focus is BOD or organic matter, and the parameter, the way we measure is the BOD basically. But nowadays also COD and also TOC, we call total organic carbon, and also COD, chemical oxygen demand, rather than BOD, because that are very quick to see what is happening and how the treatment system is performing. So in this line we will go with another topics. This is also biological treatment system. We called trickling filter design, or trickling filter, biological wastewater treatment plant treatment, trickling filter. So I have both PDF as well as PowerPoint. So we'll just mismatch whenever necessary. Sometimes we'll use the PowerPoint, sometimes we'll use the PDF version also. So let's start our journey now. Then Korean class 12টার দিকে আসতে হবে। So I will show the slide now. So we start with PowerPoint, then when necessary we will go to the PDF copy of lecture note. So lecture note is prepared just for your reading, so there is more informations are given in the lecture notes, and PDF also, I mean slide also I try my best to prepare in a way so that we can make sure we understand the thing. So as you can see, now we are in biological wastewater treatment. There are 2 things basically, or 2 systems left over. which is we call activated sludge system. Can you see the slide, by the way? Is it visible to you?
Yes, sir.
Okay. So these two systems, and between these two systems, I mean, apart from waste stabilization pond, what we discussed already, so there is the system we call activated sludge system, and one system we call trickling filter system. So basically, biological wastewater system is divided into two parts. One is called suspended growth system, one is called fixed growth system. So suspended growth means, so you know the bacteria is very important one in case of biological wastewater treatment. So we culture bacteria. So bacteria basically work for us. Bacteria take organic matter as their food and reducing the BOD content. And this is how basically in biological wastewater treatment we treat our pollutant, primarily BOD or primarily organic matter, and we measure by BOD or COD or TOC. So at the end of the final product, it produces carbon dioxide, other gases, and also water, and water goes back to the system if it qualify to discharge, and also solid things again goes for another sort of treatment to produce the, sometimes we put biogas, sometimes we produce biofertilizer, sometimes just for landfill, so something like that. And the suspended growth system, there are two approaches basically. What we have seen in waste stabilization pond, and another system is activated sludge system. So waste stabilization pond is more on open system, less expensive, less skill required in the design. You have seen already, and depends more on natural sunlight, temperature, air supply, so something like that, which sometimes is not possible in case of cold climate region, in case of urban area where land area is very, very limited, and also for advanced sort of treatment where we want everything in our control, like human control. So in pond system, human control is very, very less. So in that case, activated sludge system really works or performs better with a much more controlled system, with a very good quality of effluent is possible, but it is more skilled system. So more technical system. The technical aspects are really very high in this case. While on the other hand, trickling filter system is basically we call fixed growth system. So fixed growth means you will give a surface to grow the bacteria. So bacteria will grow on a specific surface. So that is called fixed. It's not like pond system, it is floating. So here and there, so suspended. So that is basically the initial differences is there. We call trickling filter. This is we record the surface. So a trickling filter is in the scope of our syllabus, but activated sludge system is much more modernized, advanced system, much more control system. As I said, human control is there. And you know exactly what is happening, and control is on your hand. So you can really control based on the volume, based on the pollutant, based on the system, how it performs. Just to give you a little bit idea about activated sludge system today, and then more focus will be on trickling filter. So today our learning will be much more on fixed growth system, which is trickling filter system. Okay, so let's move ahead. As I already spoke with you, there are two systems basically. One is called suspended and attached system. So suspended processor, activated sludge, waste stabilization pond, and attached growth is basically trickling filter. So there is a text available already. I discussed with you. I mean, some of the surface will be responsible to degrade the organism, such as like rocks and plastic. So these are surface. Or I might discuss earlier, like bacteria can grow anywhere. I mean, if just needed the suitable or comfortable environment for them, then it can grow anywhere. And aerobic, anaerobic already you know basically. So I think we just not repeat these things. So activated sludge system, just in a one slide description. So this is complicated as I said, but as you know, it is a aerobic suspended growth biological waste water treatment in which dissolved organic and inorganic matter can be removed. Some of the suspended and colloidal matter can be removed indirectly by sticking to the slime of the bacteria. So slime means a very sticky, little bit, what I should say, slippery surface. We can see in a water filter also, sometimes you go and then you can touch, then you can feel that some surface is slippery and little bit sticky. So that surface is called slime layer of bacteria. So sometimes some of the colloidal or suspended matter just attach with them and then remove that. That's why it says sometimes also some of the TSS can be also removed here. So this treatment is achieved in tanks called aeration tanks. So aeration is necessary, oxygen supply is necessary because oxidation process allow aerobic bacteria to work and degrade faster rate. In the aeration tank, microorganisms feed on dissolved solids, mainly organic matter. So microorganisms means bacteria feed on dissolved solid. This means mainly organic matter or what you call BOD, and produce large amount of bacteria. So the process is initially bacteria take the foods for their survival, for their growth. The number of growth is increasing. That means that microorganisms convert dissolved solids into suspended solids, the bacterial colony. That means that whatever was dissolved, like in the BOD or organic matter, we cannot see. That means when bacteria starts or microorganism starts eating, then they produce themselves, like they produce the bacteria. And then now you can see the bacteria basically. So who basically eat all the microorganisms, organic matter, reducing the BOD, now it coming as a suspended. That means we can see what is happening. After the aeration tank, a secondary sedimentation tank is installed to separate the bacteria from the liquid. Basically separate the solid from the liquid. So bacteria now become solid. If there is no more microorganism, that means there is no more food, there is no more wastewater you are giving in this tank, then obviously bacteria will die because of the food. And that bacteria basically becomes the solid. And that solid basically separated by physical process, as you know, in the sedimentation tank. So this is also a sedimentation tank. So this is secondary sedimentation tank, because primary sedimentation is belongs to the primary treatment. So that's why this is called secondary. The secondary tank is installed to separate the bacteria from the liquid, or you can say that separate the solid from the liquid, same as before. The separated bacteria is called activated sludge. So that becomes the sludge. The part of sludge is wasted and remaining part is returned back to the aeration tank. We'll see in a minute the process diagram. So what it says, when you separate the sludge, that means that is the solid. That solid become the waste if you just dump it somewhere, treating for other sort of solid treatment, or that slurry or water mixed with solid, thick slurry or solid, that can be recycled back to the system. So that is called recycle sludge. The recycle of the sludge to the aeration tank is very important to keep specific concentration of the bacteria in the system to perform wastewater. That means in earlier, I might highlight to you that when the bacteria makes a colony, some of the bacteria is very young, some of the bacteria is on the middle age group, some of the bacteria is on almost at the end of their life. So there is a kind of a mix of population, bacterial population. So that is also important to get the faster degradation by maintaining the bacteria of different ages. So some of the very young bacteria, some of the middle-aged bacteria, some of the matured bacteria, some of the very old bacteria basically goes to the wasted because they don't have that much strength to fight with the food supply. The mixture of wastewater with bacteria in the aeration tank is called mixed liquor suspended solid. We call MLSS, which is one of the key criteria for the activated sludge design. So the mixture of wastewater with bacteria in aeration tank is called mixed liquor suspended solid, MLSS. So this is basically the process diagram, as you can see. So Q is your design flow, S0 is the BOD concentration or organic matter. What is the remaining is coming into the closed tank, which is called aerated tank. Obviously, sometimes we keep this thing open, but still we supply oxygen because that is manual control. We supply sometimes if keep it open just in the climate of Bangladesh, like where we do not have the very low temperature. So we have temperature, we have air. So in that case, most of the time, to take the advantages basically from the environment, we keep the open top open so that we can allow light, it can allow oxygen. So then mechanical supply might be less. But if it is a cold country region, then if you keep it open, sometimes in the winter period like now, so the surface becomes really frozen. So in that case, all the process, all the bacteria basically died because bacteria cannot survive with very low temperatures basically. So if bacteria cannot survive, in that case, the total process, I mean, the efficiency of the tank is questionable. So in that case, they use closed. In our country, like tropical country, we use open tank system. So it's come as X. X is basically the mixed liquor. As you can see, that it's a mixture of bacteria and water. So it's MLSS. Again, S is the concentration of dissolved pollutants in the aerated tank. Dissolve means the organic matter which are dissolved. After bacteria culture, it becomes soluble basically. And V is the volume of the tank. And after the process, I mean, retention time of almost, let's say, 7-8 hours, like what we can see in maximum in aerated tank, depending on the size, depending on the concentration, not normally more than 24 hours, let's say 1 day retention. Where in case of a pond system, we can see in some of the ponds, it takes really long. I mean, 11 days, sometimes it's 7 days retention time is required. Here, 24 hours is, I mean, typical. It varies from 8 hours to 24 hours sometimes. If it is quite high, in that case, it might be higher. But because there is one advantage is we can always bring back the recycled water into the system. So this means even though the retention time is low for the initial part, then you can recycle 1 time, 2 times, 3 times. So as long as you think that there are active sludge, active bacteria is present. So that is the biggest advantages of activated sludge system. Anyway, so let's discuss this QR first. So this Q aerated tank, after mixing time of, let's say, 8 hours or 24 hours, then you bring back to the secondary sedimentation. Sedimentation tank is basically a cool process where just by gravity we separate the solid from the liquid, and then some of the, as you know, some of the sludge will go as a effluent. That means goes as a another treatment system, or maybe that is goes for a solid treatment system, and a few part of these will go as a recycle. So as you can see, the bottom side is arrow sign from secondary, and it goes back to the aerated tank, so primary. So that's why this is Q plus QR. QR is the return sludge flow rate. So you know Q, and then you become the QR into the system. So it's mixing the system. And again, this is also what is the wasted sludge flow rate, and X is basically the recycle. So if it is after recycle, then concentration might not be same as XE. It can be XR. So X is the effluent suspended. This means it's going out from the system. That's why we call effluent. And this is R means return sludge. So whatever the concentration present in the return sludge. So we are, I mean, not really discussing this portion quite a lot because it's a very complicated process. We normally discuss in the master's level. this activated sludge system. And in undergraduate, we just only gave you the idea like how this system works. And there is, as you know already, capital X is basically MLSS. It's a concentration of bacteria. And another important parameter is called F by M. So you can see this is F by M on the bottom side. It's called food to microorganism ratio. Food to microorganism ratio. So that is very important. We need food and we need microorganism, and we need to maintain this ratio, because if we have enough food, we do not have bacteria. That means also efficiency is less. If we have enough bacteria, we do not have the wastewater supply. That is also, these two are very important parameter for activated sludge ratio. We call sometimes F by M, or some people material test FM, particularly the sand, it is called F by M. It's not FM. And also MLSS concentration. These two are the very important criteria, apart from many other, obviously. I mean, designing the activated sludge, and you can see this is quite complicated equations of design. So this is mass volume analysis. So that is not a part of this. And there's an example also, just because I'm taking this slide from the master's level. So we have a few, but today what we are going to discuss is a principle of trickling filter. So we'll discuss what is trickling filter about, how we design it, what are the components. So that is basically is our today's lecture, and within our syllabus basically. So by the way, before I move into the fixed growth system, do you have, I mean, any question on activated sludge system? What we discuss, I mean, quite briefly. Anything in your mind, or any question you want to ask from activated sludge system? Anyone have any question? Hello? Hello? Are you hearing me?
Yes, sir. Sludge.
Okay, sometimes you have to give some knock, no? Otherwise, I cannot understand. Any question from activated sludge you have? No question. Okay. So if there is no question, then we go back to the slide again. So let's discuss about trickling filter. Where we are. I think this is the one. Okay. Okay, so trickling filter, the name suggests this is sort of a filter where wastewater have to trickle to pass through. And this is exactly the same thing, but it's not a filter. Rather than this is a fixed growth biological wastewater system. But it works like a filter, obviously. So that's why you call filter, and water is trickling. It means water has to have some tricks to flow through the void spaces provided in the design, basically. So that is basic principle of trickling filter. And as wastewater move through the system, there will be some process, biological process will take place. And by that biological process or principle, trickling filter basically treated the waste water. It's all very much would say very much user-friendly design. I mean, someone can really maintain it. It's not very difficult, but very slow process compared to activated sludge. However, compared to a stabilization pond, might be a little bit faster, but require a lot of maintenance and washing, cleaning, so something like that. So it's necessary, the trickling filter. So let's see what is it about. Both biological system. What do you mean by aerobic? It means air is present here on the surface, top of the surface, and this is a move here and there. What you can see in the waste stabilization pond as well as in the activated sludge system. Rather, it will be fixed. So that's why it's called aerobic attached growth. Aerobic means aerobic bacteria. Attached growth means the bacteria will grow in a surface, on some surface. The major components of the trickling filter are the tank, so where it will be made of. So basically, if it can be closed system, it can be open system. I mean, base or tank is necessary. Rotary distributor. This means water cannot be just thrown into the filter. And if you throw it, that means you damage the surface of the bacteria. I mean, bacteria cannot take that much of load. So it's mostly like a sprinkling system of water. So I will show you the however, if you can just if you just and this is so this is where it's a small opening here, the sprinkler, and this basically rotate like this, okay, like this, and then when it is rotated, okay, so that is basically filter media. This is filter media. Also filter media. Typically this is stone, crushed stone. Typically it's produced by crushed stone, gravel. So, nowadays it becomes the plastic. Also is very area is limited, so use of plastic is also nowadays is very common. But typically trickling filter tips also. Then after process over, I mean, when it's trickled down from, this is basically, as you can see, the water basically comes here. Let's say, so let's say okay, so ultimately it reached here, and while it so almost treated water, we believe, and then this under less amount of BOD, or maybe almost ready to, so that is under drain system, and there is a ventilation on the top because this is open, it's not closed. So it's a ventilation. So sometimes you know exactly in the void when there is no water, obviously. Biological process is basically the bacteria